Hello viewers, I am Kausalya. Today we are going to solve problem number 8 under the topic BODE plot. The problem is a unity feedback control system has this transfer function. Draw the BODE plot, find gain margin, phase margin, gain crossover frequency, phase crossover frequency, and also comment on the stability. So here the initial step is we have to draw the BODE plot, and from the BODE plot we have to find out all the remaining factors which are asked here. And finally we have to tell whether the system is stable or unstable, right? So this is the given problem, and in the problem they had clearly mentioned it is a unity feedback system, right? So the value of h of s is 1 here. So the next thing is, when you look at the problem, you see it is not in the standard format. The previous problems are in the format of 1 plus some number along with s, right? But here you see s remains single, that is coefficient of s is 1. Here also 1 and here also 1, right? So this is not in the standard format. So here we are going to modify this given problem. So the first thing is, in the denominator part we are taking the numbers outside. So here we are having s plus 2, right? Here 2 is taken outside. So when you take 2, what happens? S by 2 plus 1, right? Similarly in s plus 20, here 20 is taken outside. So when you take 20 outside, the remaining terms will be s by 20 plus 1, right? Then what happens? You see, when you cancel the terms, so 2 and 80, when you cancel you will be getting 40, and you cancel 40 and 20, the answer will be 2. So our simplified format is here 2 divided by s into 1 plus, here 1 plus 1 by 2 is 0.5, so 0.5 yes, and here 1 plus 1 by 20 is 0.05, and this s here s, right? So the next step is we have to replace s by j omega. So when you replace s by j omega, you see here we will be having our expression like this, that is s is replaced by j omega, that's it, right? Then the next step is we are going to follow the steps for magnitude plot. So for magnitude plot, the first step is calculating the corner frequencies, right? So how to calculate corner frequencies? We have to take the reciprocal of the coefficient of s or reciprocal of the coefficient of omega. Both are same, right? So here what is the coefficient of omega for this term? It is 0.5. So when you take reciprocal, the answer is 2. And similarly, when you take the reciprocal of this term, 0.05, that gives the answer as 20 radian per second, right? So here the corner frequency should be given numbers depending upon the ascending order. So here the least value is 2, so this corner frequency is named as 1, and the next higher value is 20, so here it is named as 2, right? The next step is we are going to form our table 1. So this is the given problem, right? So our table consists of 4 columns: term, corner frequency, slope, and change of slope. So how to arrange the terms here? So the first term should be constant along with individual omega. So here we are having 2 divided by j omega. So this term should be written first. So here I had written 2 by j omega, right? Then the next thing is, depending upon the value of corner frequencies, we have to arrange the remaining terms. So here the first corner frequency is, that is the least value is 2, right? So which term contributes to this term? That is 1 divided by 1 plus 0.5 j omega. This term gives a corner frequency of 2. So here we have to write that term. Then the next corner frequency is 20. So which term contributes 20? This term contributes 20. So 1 divided by 1 plus 0.05 j omega contributes a corner frequency of 20, right? So after writing this, next we have to frame the slope. So how to write the slope here? An omega in the denominator, this gives a slope of 20 decibel. Since it lies in denominator, here it gives minus 20, right? Similarly, here also omega is in denominator term, so this gives minus 20, and again here omega lies in denominator and this gives a slope of again minus 20, right? So the next thing is we are going to calculate the change of slope. So change of slope, the method to calculate is we have to write this slope here as such, and we have to move this slope to the right hand side. So here you see minus 20, and here this minus 20 is moved to the right hand side. So here we are getting minus 40, right? So again when you move this minus 40 downwards, again you have to shift this minus 20 to the right hand side. So minus 40 minus 20 gives you minus 60, right? So our table 1 has concluded here. Hope you people understand well, right? Then we are moving to calculate the magnitude. So for calculating the magnitude, we have to select two frequency values in such a way that the omega L, it should be less than our first corner frequency, and omega H, this should be greater than our second corner frequency, right? So here we are having omega C1 as 2, right? So select a value which is less than 2. So here I had selected 0.1. Again, omega C2 is 20, omega H should be greater than omega C2, right? So here I had selected the value as 100. It is up to you. Even you can take 50, and here even you can take 1. Okay, everything is right. So the next thing is we are going to find the value of magnitude for all these 4 values of frequencies. So here A is given by, A is nothing but magnitude, right? So this is given by mod of G of j omega in dB. We are calculating the magnitude in decibels, right? So first at omega equal to omega L, here for omega L and omega C1, we have to find the value of magnitude using constant and individual omega terms. Right, since we need in dB, here we are including 20 log, right? So 20 log. So what is the value of constant and omega? You see here I am having 2 divided by omega lies in denominator. So here we have to include 2 by omega, right? So here 20 log of 2 by j omega. So what is the value of omega L? Omega L is taken as 0.1. So just substitute the values here and find out the answer. The answer is 26.02 dB, right? This is done by using a calculator. The next thing is at omega equal to omega C1, again we have to use the same formula here. So 20 log, here the value of omega C1 is 2. So 2 by 2, so log 1 is 0. So here the answer is 0 decibel, right? At omega equal to omega C2, here the formula is different. You see, change of slope from omega C1 to omega C2 into log of omega C2 by omega C1 plus the value of A when omega equal to omega C1, right? So what is the value of change of slope from omega C1 to omega C2? Here we have to look at the table. So this is our omega C1 and this is our omega C2. So change of slope from omega C1 to omega C2 is, you see, from omega C1 to omega C2, what is the value of change of slope? It is minus 40, right? So we have to write it over there. So minus 40 into log of the value of omega C2 is 20 and omega C1 is 2, right? Plus the value of A when omega equal to omega C1. Just now we had find out, right? So at omega equal to omega C1, what is the value of magnitude? It is 0 dB, right? So just substitute. So here the value is 0, right? So once you solve, you are getting the answer as minus 40 decibel, right? And the next thing is at omega equal to omega H, the formula is change of slope from omega C2 to omega H into log of omega H by omega C2 plus again the value of A when omega equal to omega H, right? So change of slope from omega C2 to omega H is, so this is our omega C2, right? So what is the value of omega H? I have taken it as 100. Right. So when you write it in the table, it will be, we have to write it after omega C2, right? So from omega C2 to omega H, what is the change of slope? Here I am having this minus 60 and this minus 60 will be shifted downwards, right? Here you see minus 40 and this minus 40 is shifted downwards. Similarly, this minus 60 will be shifted downwards. So the change of slope from omega C2 to omega H is minus 60. So just substitute it here into log of omega H is 100 and omega C2 is 20, plus again what is the value of A when omega equal to omega H. So sorry, here omega equal to omega C2. So when omega equal to omega C2, what is the value? It is minus 40, right? So just substitute the values here. So finally we are getting the answer as minus 102 dB. So finally I am framing a simple table which includes our frequencies and magnitude. Then it will be easy for us to plot, right? Next we are going to frame an expression for phase plot, and this is the given problem. So here the phase plot, it is given by represented by pi. So an omega is always contributing a 90 degrees. Since it lies in denominator, I am going to shift this to the numerator part. So here I am writing minus 90. Similarly, when you look at this expression, it is nothing but tan inverse of imaginary coefficient. So here the imaginary coefficient is 0.5 divided by 1. Again, this is a denominator term. I am going to move this to the numerator. So here a minus is included, right? Again, when you look at this third term, what is the imaginary coefficient? It is 0.05 omega divided by the real term is 1. So again this is a denominator term. I am going to move this to the numerator part. So here tan inverse of 0.05 omega. Right. I already said a constant never contributes any angle. So here the angle contributed by this number 2 is 0. So here we are not writing anything. Right. So after framing this, we are going to form our table 2. Here, while selecting the values of table 2, you must include all the values of frequencies which we had used to calculate the magnitude. So here previously we had included 0.1, 2, 20 and 100. So here similarly you see 0.1, 2, I had included 20 and 100. You can include in between values also. When you have minimum of 7 to 8 values of frequencies, then you will be having a more accurate phase plot. Okay, that's the reason why we are including more number of frequencies here. So for these values of frequencies, just substitute the values over here. Right, even you can directly substitute the values by using a calculator, or you can form table like this and you can write down the values for each and every term, and finally you can simplify. Okay, any way is correct. So after finding out the values, right now you can calculate these values using a calculator. Okay, a calc will do all these things. The only thing is you should careful while typing, that's it. Right, so after finding out the values of this phase angle. After finding the values of phase angle, we are going to mark it on a semilog sheet. So this is our semilog sheet. In x-axis we should take always frequency, and this left hand side y-axis stands for magnitude and the right hand side y-axis stands for the phase angle. Right, you can mention here this is a phase angle and this is for magnitude. Right, now we are going to mark the points for magnitude as well as for the phase angle. So here the first value for magnitude is at a frequency of 0.1, the magnitude is 26. Again, scaling is only up to you. You can take the scale depending upon the values you get. Right, no need, there is no compulsion, you should always take like this. This is just like drawing a graph sheet. In graph sheet we will be taking according to our wish, right? Similarly you can do here. So the first point is 0.1, magnitude is 26. So you see this is my 0.1. So at 0.1 the magnitude is 26. So this is my first point. And the second one is frequency is 2 and magnitude is 0. So frequency is 2, right? So the 2 lies between 1 and 10. So when you look from top, this is my 1, then this is my 2. So at 2 the magnitude is 0. So just mark a point. Similarly, at a frequency of 20 the magnitude is minus 40. So again come down. You see between 10 and 100 lies 20. When you move gradually upward, this is my 10 now and this is my 20, right? So at 20 the magnitude is minus 40, so just keep a dot here. And the last one is frequency is 100, magnitude is 102. So here you see this is my 100, right? The frequency is 102. So here lies my 100 line. So here it is 102. Now we are going to join these dots by using a scale, right? Let me show you. So first we have to join these two dots, and next these two dots, and finally these two, right? Now we are going to write the slope for these different values of straight lines. So here how to write the slope? Again we have to look back at our table. So here what is the first value of slope? We have to start from here. It is minus 20, right? So here this is our minus 20. So minus 20 decibel per decade, right? Again you have to look back at your table. So what is the change of slope here? It is minus 40, right? So this slope is the minus 40 slope. So it is minus 40 decibel per decade, right? Again what is the final value of change of slope? It is minus 60. So this is our minus 60 slope, right? So after writing these things, it is always mandatory to highlight your 0 dB line, right? It is a must. So then now we are going to move to our phase plot. So these are the different values of phase angle for the respective frequencies, right? Again, here at a frequency of 0.1, the phase angle is minus 93. I will show you how to mark. You see, here I had selected the angles. So here I had started from minus 80, minus 100, and it goes up to minus 260, right? Again, the scaling can be done as per your wish. The first thing to be done is you should always highlight your minus 180 degree line, right? You see, it is mandatory. After highlighting, then you can mark the each and every phase values here. So the first phase value is 0.1 and the phase angle is minus 93. So here is my 0.1, right? And here is my 80 and here is my 100. So between 80 and 100 lies my minus 93. So here it is marked over here. This is my first point, right? And the second point is 1 and the angle is 119. So this is my 1. Right, and here the angle, this is my 120, and here lies just a little bit above lies my 119. And the third point is 2, angle is minus 140. So again you see between 1 and 10 lies 2. So when you move upwards, this is my 1 and this is my 2. At 2 the angle is minus 140, right? So here is my minus 140. So this is my 2. So this is that point, right? Likewise, you just mark all the remaining points. So after marking the points, you have to join all these dots by using freehand, right? Let me show you now. I had just inverted the semilog sheet. Just you can join like this. Right. So finally, this is our phase plot, right? So now we are going to find phase crossover frequency and gain crossover frequency, right? So what is your gain crossover frequency? The frequency at which your magnitude is 0 dB. That gives your phase crossover frequency. So when you look carefully, you see here, this is the point where my magnitude becomes 0. Right. So at this point we have to find what is the value of the frequency. So just by using a scale you can easily find out the values. So here you see this is my point, and when you observe carefully, right, this is approximately 2.1. So the value of gain crossover frequency is 2.1 radian per second. Right. The next thing is we are going to find the gain crossover frequency. Sorry, phase crossover frequency. So phase crossover frequency is that particular point where our phase plot meets our minus 180 degree line. So this point exactly. Now we are going to find the value here. Again, just to keep a scale over here. You see, when you keep the scale and when you observe, you see it is approximately 6 point something. Move like this. So it is approximately 6.3. So that is your phase crossover frequency. So it is 6.3 radians per second. Right. Am I making you the concept clear? If you want, even you can keep the scale and you can draw some dotted lines like that. But I am not comfortable by drawing like this. When you draw lines, it won't give you that much good look. Right. So just keep a scale over here and finally just look at the point. Look at exactly what is the point. If you have any doubt, you can just observe from the top also. Okay, everything is right. But you should be specific in writing your gain crossover frequency values and phase crossover frequency values. Right. So now this part is over. Now we are going to calculate gain margin and phase margin. So how to calculate the gain margin and phase margin? Again, you see, from this point, okay, from our gain crossover frequency, you just draw a line. Right. So when you draw a line, you see it is meeting our phase plot at a particular point. Right. Right. So at this particular point, you just measure what is the angle. So at this point, you see what is the angle? The angle is minus 140. Right. So here the value is given by, just we can write, phase margin is given by, this is the formula, 180 degree plus pi gc. Right. So here 180, what is the value of pi gc? Here you can even mention, right? You see it is exactly 140. Even you can draw a line or you can simply mention here that that is the value of this pi gc is 140 degrees. It is up to you. No compulsion that you should always draw a line over here. Right. So here once you substitute, it is 180 minus 140. But then what will be the answer? It is plus 40 degrees. Right. So the phase margin is over here. Now we are going to calculate what is the value of gain margin. Right. So to calculate the gain margin, again, the thing is, here we had find out our phase crossover frequency, right? So from this frequency, just draw a line. It will meet our magnitude plot at some point, you see. So here from this point, just draw a line. Right? It is meeting at some particular point. So at this point, right, just you note what is the value of the magnitude. So how to measure the magnitude? You see, it is just keep a scale and you can measure, right? It is approximately equal to some around 22 dB. Is it clear, right? You see, here it is minus 20, right? And here it lies just a point below here. So it is around 21 point something or some 22, right? Because it is minus 20 and this is minus 40. So here the gain margin value is nothing but it is 22 dB, right? So here now we have to tell whether the system is stable or not, right? So whenever you are finding a gain margin below 0 dB line, that is said to be positive gain margin. Okay, this is plus 22 dB. And again, whenever you are finding a phase margin which is above your minus 180 degree line, then this is said to be a positive. So here we are having a positive angle of 40 degrees. When both the phase margin and gain margin values are positive, then what about the stability of the system? The system is said to be perfectly stable, right? This problem is quite bigger, I know. It took time to understand. So just always sit with a semilog sheet, scale, paper, etc., whatever things you want. whatever the steps I am telling, you can draw instantly, then only you will be having lot of doubts. If you have any doubts, let me know in the comment section. Hope you people understand the video. I had done my level best. Thank you.